Welcome to today's Explainer. I am absolutely thrilled you're here because we are unpacking a complete paradigm shift in how we manage and govern advanced artificial intelligence. We're going to dive into a groundbreaking approach called the WARDEN architecture, which literally redefines how we establish trust in AI systems operating out there in the real, physical, and digital worlds. Let's get right into it.
For the past few years, the entire conversation around AI safety has been completely hyper-focused on one thing: the model itself. We're constantly asking, is this model compliant? Or, hey, is this model aligned? But as these systems scale up at lightning speed, there's a massive question we have to ask ourselves. Are we actually securing the wrong part of AI? Because starting AI governance purely with model compliance is increasingly looking like the absolute wrong approach.
See, in the past, this focus was entirely contained within a safe little software bubble. We were just testing a model's outputs in a lab. But in our new reality, AI models don't just sit in a vacuum anymore. As they get more capable, they operate through sprawling, incredibly complex infrastructure. We're talking about vast networks, APIs, autonomous machines, sensors, physical environments, the whole shebang. When an AI can suddenly control a robotic arm in a factory or reroute sensitive data across a global network, the entire governance problem changes overnight.
So here is our roadmap for today. 1. The AI governance problem. 2. The WARDEN architecture. 3. The evidence reduction funnel. 4. And this is absolutely critical, why RTF matters for trust. 5. The role of spatial context. And finally, 6. Human authority in AI.
Section 1. The AI governance problem. Moving beyond the model.
When an AI system operates autonomously out in the wild, knowing that its core model somehow passed a safety test 6 months ago, well, that doesn't really help you much today. The real problem, the vital new questions organizations literally must ask are things like, what is happening right now? What evidence supports that conclusion? How trustworthy is that evidence? And maybe most importantly, what authority should the system actually have as a result? You just can't answer these questions by staring at the AI's source code. You have to look at its environment.
Section 2. The WARDEN architecture. Separating visibility from control.
Okay, so WARDEN isn't just some basic monitoring tool that shoots you an email when a server goes down. It's an evidence reduction architecture. Its whole job is to maintain trustworthy situational awareness across both digital and physical domains. But here is the secret sauce. It does this without collapsing awareness into authority. Just because an AI system needs massive, broad visibility to understand an environment does not mean it should automatically be handed equally broad control to act on it. Instead, broad observation has to produce narrow, strictly evidence-backed authority.
Section 3. The evidence reduction funnel. The inverted triangle.
Modern infrastructure pumps out more data and telemetry than any human or organization can possibly reason over. The problem isn't a lack of data, it's figuring out what actually matters. WARDEN tackles this by visualizing an inverted triangle. At the very wide top, you have a massive observation surface: identities, network behaviors, sensors, operator activity. First, you observe. Then, you move down the funnel. You correlate all those messy signals. You reduce the evidence down to a manageable operational state. And finally, at the very narrow bottom tip, you hit the decision surface. That's where you authorize.
Now, what's truly fascinating here is what happens during that reduction process. WARDEN doesn't just smash data together to spit out some clean, fake certainty score. It's built entirely on a fail-closed principle. During reduction, it meticulously preserves the provenance of the data, the level of confidence, the recency, and any behavioral drift. And crucially, it preserves disagreement. If a smart sensor completely conflicts with a network log, WARDEN doesn't ignore it. It retains that contradiction. It evaluates the true risk based on what's missing or conflicting, rather than just hiding uncertainty behind a big green checkmark.
Section 4. Why RTF matters for trust. The temporal nature of evidence. Now, if you take only one thing away from our deep dive today, let it be this section. Because RTF, the real-time factor, is the absolute beating heart of this entire system.
I want you to really anchor on this profound realization. Trust is temporal. In the old world of IT, we kind of treated trust as a static credential. You log in, you get authenticated, boom, you are trusted. Forever. But in an advanced AI ecosystem, a fact about a system can become outdated almost immediately. Trust is not a permanent state, it is a decaying asset.
To see exactly why this real-time factor is absolutely essential, imagine time zero. At T0, an identity is perfectly valid. The machine is healthy, great. But let's say at time plus 1 hour, the machine's behavior starts to slightly drift. The AI model starts producing a totally different pattern. By time plus 2 hours, that original trust is completely compromised. If you lack temporal weighting, if you just ignore time, that time zero observation quietly becomes a permanent, unquestioned assumption. In a live system running critical physical infrastructure, operating on 2-hour-old trust is unimaginably dangerous.
To combat this, Warden uses RTF to treat evidence as something whose operational value is constantly changing. It's rapidly and continuously firing off these questions. How recent is this signal? Is the source still reliable right now? Has the environment changed since this signal was issued? Has newer evidence popped up? Does that new evidence reinforce or contradict what we thought we knew? And finally, how much confidence should we still have? By constantly filtering evidence through time, RTF ensures that a system's authority is never based on stale, dangerous assumptions. Time governs trust, period.
Section 5. The role of spatial context. Trust exists in relationships.
The big takeaway here is that spatial awareness goes way, way beyond just a geographic location on a map. We are talking about understanding entities in relation to one another across digital, network, physical, and organizational space. Think about it. A completely trustworthy AI component, operating exactly as designed in a vacuum, can suddenly become a massive risk purely because of what it's connected to or where it currently sits in a network.
Let me give you a few examples. Consider a standard network event. On its own, totally harmless. But when Warden correlates it with a sudden physical location change, it suddenly becomes a severe threat. Or imagine a physical AI agent, like a robot. It might be functioning perfectly. Its internal diagnostics are totally great, but it's physically rolling into an unauthorized area. Or how about a sensor reporting correctly according to its own firmware, but completely disagreeing with 5 other trusted sources right next to it? Spatial relationships entirely change the meaning of individual signals. Evidence only actually matters when you understand the context around it.
Section 6. Human authority in AI. Keeping control bounded.
This brings us to one of the most important architectural boundaries in Warden. Awareness does not automatically create permission. As we noted earlier, an AI system absolutely can and should understand vast amounts of complex information, but that doesn't mean it's allowed to just act on it. This separation is highly deliberate, and it acts as the ultimate failsafe.
Standard automations operate on a pretty scary simplistic loop. Detect, then act. It's immediate, it's fully automated, and it is highly prone to cascading failures if that very first detection was flawed. Contrast that with Warden's structure. Observe, correlate, recommend, and only then authorize. The system can surface a risk, it can strongly recommend responses, but high-impact actions remain constrained by rigid policy and, crucially, explicit human approval.
When you combine all these pieces, the reduction funnels, the vital real-time factor, the spatial context, the bounded authority, you achieve something called governance dominance. And this isn't about having total, heavy-handed, unrestricted control. It's about having a far more accurate, current, and evidence-backed representation of operational reality than the actual systems around you. You pull this off by observing the environment, preserving providence, constantly accounting for time, identifying contradictions, and bounding authority.
As AI models inevitably get faster, smarter, and way more integrated into our physical infrastructure, raw intelligence just isn't going to be enough to keep us safe. The core thesis for the future of AI governance is this: evidence first, context preserved, authority bounded. The ability to truly understand what is actually happening around these AI models is going to be the defining operational advantage of the future.
Which leaves us with a pretty provocative final question to consider today. As autonomous systems scale across our digital networks and physical infrastructure, will we actually have the architecture in place to govern their intelligence? Or are we just going to sit back, watch it emerge, and hope for the best? By prioritizing time, context, and hard evidence, architectures like Warden give us a real path to maintain true trust. Thank you so much for joining me on this Explainer today, and I really hope this sparks some fresh thinking on how we govern the AI of tomorrow.